All right, today we are doing 1-4 in pre-cal, which is Extrema and average rate of change. Today's date is today. Our objective is to determine intervals on which functions are increasing, constant, or decreasing, determine maxima and minima of functions, and determine average rate of change of functions. So we've got a lot going on today. All right. A function is increasing. I'm sure you guys are asking yourself, what does that mean? Pretty much, this is going to be the math speak of it. A function f is increasing on an interval L if and only if, for any 2 points on L, a positive change x results in a positive change of fx. All right, that's a mouthful. What that really means is if you're looking right or from left to right like you read, and the graph is going upwards, it's increasing. Same thing for decreasing. If you look going from left to right like you are reading, and the graph is going down, or your y values are going down, it's decreasing. And if it stays the same, it's constant. So this is the math speak. That's what it really means. So on this one, we've got x cubed minus 3x as our graph. We want to determine where the function is increasing, decreasing, or constant, and support your answers graphically and numerically. Well, numerically is we would make a quick t-table. So if we want to choose some values, I would choose some negative, -2, -1, 0, and then I choose some positive. And then you just plug those in. See, 3 would be 20. That one's going to be off the graph, but that'd be 27 minus 9, which is 18. Kind of gives us an idea. So, where is it increasing? Well, I'm going to get my highlighter out on this one. That's where the graph is going upward from left to right. So, let's highlight where it is increasing in green. So right there, the graph is going up. Oops, it looks like I have it on the line instead. All right, there, the graph is going up. And right here, my graph is going up. So that is where it is increasing. It is decreasing right along here. Not sure exactly why that's going into a straight line, but you can visualize it. So, where it is increasing, I'm going to use function notation to designate that. It's going from -infinity. Even though we don't have it written there, there's an arrow there. And then my x value, right there, is 1. And it doesn't really include that 1 because we call that a point of inflection where it's changing direction. And then it's also increasing here from 1 to infinity. And when I do this, I'm looking at my x values. So from here onward, it is increasing. So decreasing, I'm going to look at my x values again. It's decreasing from when x is -1 to +1. So -1 to +1. And remember, I'm using function notation. This is not an ordered pair. And there's no place on here where it's constant. There's no place where I've got the same y values. And if I look at my t-table, this makes sense. It is increasing. My y values are getting bigger, and then they get smaller and bigger. So you can look at that t-table. I personally think it's easier to look at the graph, though. I'm more of a visual person. All right. Take a second, hit pause, try this one on your own. All right, on this one, this is a parabola, and it is decreasing along this part of the graph from negative infinity to when x is 1. And then it starts increasing. So if I wanted to put that in function notation, my increasing is from negative infinity, because what's happening is it's going along here all the way to negative infinity, and that's where it's changing directions, is at 1. Imagine that's a comma. That's not a very good comma. And then, did I put increasing? I meant to put decreasing right there. I'm sorry. That is where it is decreasing. It's going down. It's increasing from positive 1 all the way to infinity. And if I were going to look at my end behavior here, as x goes to negative infinity, y is going to infinity. As x is going to positive infinity, y is going to positive infinity. Does not look like there's any place that's constant on here. All right, critical points. I'm going to let you kind of pause and read some of this on your own. This is some of the math speak of it, but I'm going to try and break it down so that it's pretty understandable. Extrema, that's pretty much a high or a low point on a graph. A relative maximum, that's the top of a hill. Absolute minimum or absolute maximum, that is the tallest part of the entire graph. A relative minimum, that's at the bottom of a hill. The absolute minimum is the smallest part of the graph, or the lowest part of the entire graph. So right here, we've got a relative maximum there, relative maximum there, relative maximum there. This one is also our absolute maximum. Minimums, bottom of a graph. So right here, we have a relative minimum and another relative minimum right there. So 3 relative maximums, 2 relative minimums. All right, rate of change. You want to get that formula down. The average rate of change between any 2 points on the graph of a function is the slope of the line through those 2 points. So that line is called the secant line, and the slope is your rate of change. So I have a graph here that is in the black. That's my function. So if I want to find the rate of change between those two values of x, there are my values of x, I'm going to have to find out what my values of y are. So right there would be f of x plus 1, x sub 1, I'm sorry. Right here would be f of x sub 2. And then you just really plug it into that formula. So on this one, we're going to find the average rate of change of f of x equals negative x squared on the interval from -2 to -1. Well, hopefully you've got parent functions pretty well down, and you know negative x squared is just a parabola that looks something like that. And we're doing it from -2 to -1. So you're doing it from, let's try and draw that just a tad better. From that point to that point. And I give myself a C- on drawing ability on this one. But you're finding the slope of that line from when x is -2 to -1. So we need to figure out what our outputs are. So I need to find f of -2 and f of -1. Well, when I do that, I'm going to get -4, because -2 squared is 4. Then you put your negative sign. That negative sign is not being squared, and that's going to be -1. So that's going to be, go back to our formula, f of x sub 2 minus f of x sub 1. That's a very fancy way of saying y sub 2 minus y sub 1. Oops, wrong direction. So -1 minus -4 over our x values, which are -1 minus -2, which is going to give me -1 minus -4 is the same as 1 plus 4, -1 plus 4. And that's going to be -1 plus 2, which is 3. So the average rate is 3. Take a second, pause, try this one on your own. When you are ready, hit the unpause button and check your answer. On that one, I got -1, which makes sense because it'd be from 0 to 1, it's decreasing. So I should have a negative slope. All right, hope you enjoyed.